Hello everybody, how are you doing? Hope everybody is going great for you and that you are having a good day. So in the last video we talked about the comparison test. We saw an example. So in this video we will learn about a new test which is called the ratio test. So let's go for it. The ratio test for positive series. The positive series sum of AI converges if the ratio limit of an plus 1 over n going to infinity exists and is less than 1. It diverges if the limit exists and is greater than 1. Or infinite. If the limit is equal to 1 or fails to exist, then the test gives no information. Right now, let's prove that the ratio test is valid. Proof. Suppose that limit of an plus 1 over n going to infinity is equal to L being less than R and R being less than 1 or some R. Then after some point k in this sequence, all the terms are within R minus L of L and so R less than R. Then AK plus 1 should be less than R AK plus 2 should be less than R AK plus 1, which is less than R square AK. So, comparing AK plus 1 plus AK plus 2 plus ... with AK plus R AK plus R squared AK plus ... gives convergence since the right-hand series is a convergent geometric series. We may argue similarly to deduce divergent if L is greater than 1. Let's look at an example. The series sum of 1 over I raised to the power s, which is the Riemann zeta function, for various values of s sometimes converges and sometimes does not. For example, when s is equal to 2, it converges to pi square over 6. But for all these series, the ratio test is inconclusive since limit of an plus 1 over an when n goes to infinity will always be equal to 1. Conclusion: the ratio test is a less powerful test than the comparison test. So that's pretty much it about the ratio test. In the next video, as always, we will look at more examples, we will practice, so you will understand better what you just see here. So like the video, comment, subscribe if you are not already, and I say you bye. See you in the next video.